Hey guys, today as we discussed yesterday is going to be a video lecture since I'm at the district office with a math meeting. So I'm going to go through the lecture, I'm going to tell the pause here and there. So whenever we get to the end of a section, I'll just say, hey, pause this right here. Pause it, take your notes, make sure everybody's on the same page before moving on. And then I'll go through some example problems after each section to get you a feel for what you're going to be seeing during the homework. And then, again, pause as needed. And then once we're all done, you can go ahead and get to your work time. Please help each other out. If you have questions, ask each other, work together. You guys are awesome. I know you're going to do really well with this, and looking forward to being back with you guys tomorrow. So today, we are doing inverse variation functions. Before we get to the inverse, I want to first remind us about the direct variation, which are the other type of variation functions. So a direct variation function takes the form of this y equals kx. It ends up being a linear function that has some kind of constant, or in your case you might know this as slope. So if we look at a table, you'll notice that as the x increases, y has to also increase, or vice versa, as x decreases, y would also decrease. So in this case, we're going from x goes to 2, y is 4, and so I'm going to be multiplying everything by 2, and so 2 times 2 is 4, 4 times 2 is 8, 7 times 2 is 14, and 8 times 2 is 16. So in this case, every x gets multiplied by 2 to get to y. So my direct variation is going to equal y is equal to 2x, where 2 is my constant term for every x or input I want to put in. I'll multiply by 2, get my output as my y. A few more quick examples. Second one over here, we just did this when we already said it was y equals 2x. This one over here, we're going to look for another pattern. We're multiplying. So from -2 to -4, we'll notice that, hey, we're multiplying by 2 again. 0 times 2 would be 0 still. 2 times 2 is going to be 4. And then 4 times 2 is 8. So this is not following the pattern, in which case this is not a direct variation. So again, we're looking for that constant term. And with inverse variation, we're going to have a very similar looking for a constant, except the equation setup's going to be a little different. In this case, our equation is going to be y equals k divided by x instead of multiplied by x. And the nice thing with this equation, again, our k, here's our constant term, is we can actually go ahead and multiply through both sides by x. So x times that times x. The x times x or k divided by x times x cancels. And so we're actually just left with x times y equals k. This comes in very, very handy when we are going to look at our tables then to determine if indeed there is inverse variation. So let's look at a table. I'm again going to use this nice equation over here, the x times y equals k. I'm looking, first of all, you'll notice that as x increases, y is going to decrease. So it actually goes the opposite of direct variation, hence the inverse variation. And so as my x decreases, my y will increase, or vice versa. So I'm looking for, is there a constant? If I multiply my x and my y, do I get a constant? If that is true, then it's an inverse variation. If it's not true, then it's not. So I'm going to multiply straight across. 1 times 24 equals 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. Because every single one of those, the product is 24, this would indeed be an inverse variation setup. This would fit our equation. To write our equation, all we're going to do is take this constant term now, this is our k, and plug it in. So I'll have y is equal to 24 over x, or you can write it as x times y equals 24. You can pause here for notes, and then we'll pick it back up with doing a few more examples. A few examples for us now. Determining whether or not these two tables would meet the inverse variation requirements. Again, that means that we have x times y is going to be equal to a constant term. So we'll start with this first one. 1 times 12 is going to equal 12. 2 times 6 is 12. 3 times 4 is 12. And 4 times 3 is 12. So this one checks out. We can then write our equation as either y is equal to 12 over x. Again, just taking our constant term here, plugging it in. Or the alternate version, we can do xy is equal to 12. Looking at our second table, negative 2 times 20 is going to be a positive 40. And then 1 times 20 is going to equal 20. And obviously already you can see that this one is not going to fit the pattern because we have two products that are both different. Continuing on though, 4 times 5 equals 20, and then 5 times 3 equals 15. So this is not inverse variation because all of our terms do not have a constant product, and therefore it's not. The next step is going to be writing an inverse equation. Again, I put my two options for our equation up here in the right-hand corner. This one says if x equals 3 when y equals 12. So we can write this equation. First thing we need to find out is our constant term. So just like we did before with our tables, we're going to write our equation of x times y is equal to k. We can go ahead and substitute our values of x equals 3 and y equals 12. So I'll have 3 times 12 equals k. 3 times 12 is 36, being my k term. Once I have my k, I'll go ahead and plug that into my equation. So my equation for this situation will be either y is equal to my constant term, 36 over x, or x times y equals 36. Again, pause for notes. Let's do one more example. In this case, we have some negatives involved. So if x equals negative 2 and y equals 4, I'll again take my simpler equation on the bottom of x times y equals our constant term. Plug in my values. X is negative 2 and y is 4. Negative 2 times 4 would be negative 8 equals my constant. So I'll now write my equation of y is equal to negative 8 over x, or x times y equals negative 8. Our last section today is going to be looking at how to now graph an equation. On your homework, you will have a few questions that say you're going to have to combine actually the last example with this one. So we'll give you an example that says if x equals 3 and y equals 5, graph the function. So you'll first write your equation, then after writing it, go ahead and graph it. So assuming we have our equation first, however, how do we graph this? The first thing I'm going to say is choose your points wisely. What we're looking for, again, is two numbers that would multiply, so x times y equals 8. So two numbers that multiply to 8. And so, for my x, let's choose 1, 2, 4, and 8. And then, so my y terms would be 1 times 8 would equal 8. 2 times 4 equals 8. 4 times 2, 8 times 1. So I can go ahead and plot those points on my graph. 1, 8 is going to be right up here, just off my graph. 2, 4, 4, 2, and then 8, 1. So it's right over here. And you'll notice it has a kind of sloping curve down feel here. If I connect my points. And there is actually just one part of my graph, because there are also negative numbers that we can multiply to get to 8. I could also use negative 1, negative 2, negative 4, and negative 8. Extend my line a little bit. Negative 1 times a negative 8 negative 2 times a negative 4, negative 4 times a negative 2, and negative 8 times a negative 1, all would be equal to 8. So I do have actually two parts to my graph. It's going to have one up here in the first quadrant, and the other one's going to be down here in the third quadrant. So applying my points, negative 1, negative 8, it's going to be just down here, negative 2, negative 4, negative 4, negative 2, and negative 8, negative 1. Notice the shape of these graphs. They will never touch the axes, at least in this situation, because we can't plug in 0. So our axes, or x and y axis, actually act as what's called an asymptote, or something that the graph will never touch. The reason obviously being you can't divide by 0, so x can't be 0. And if y was 0, you couldn't multiply 0 by anything to get to 8. And so we'll never have that graph touching the x or y axis. You can pause there, take some notes, and then I'll do a few examples on the next page. Do one more example here. We have y is equal to negative 12 over x. Again, I'll go ahead and change this into the other form of x times y is equal to negative 12. This helps me see a little bit what the factors could possibly be. So numbers that would multiply to negative 12, the factors of 12 would be 1, 2, 3, 4, 6, and 12. And so 1 times, I'll have to do, here's my x, here's my y, a negative 12. 2 would be times a negative 6, 3 times a negative 4, 4 times a negative 3, 6 times a negative 2, and 12 times a negative 1. Notice we are getting quite a few options here. On your homework, just stick to all the values that are going to be less than 15. If you do have a lot of higher numbers that have a lot of factors, you can stick to the numbers that are smaller. Just get a good idea of what's happening right around the origin and the inside part here. And so I'll go ahead and start graphing these. My first one is 1, negative 12, which doesn't really show up in my graph, so I'm going to just skip that for now. 2, negative 6 is right here. 3, negative 4, 4, negative 3, and 6, negative 2. So my graph's going to be right here. And then, of course, I also need to flip all these. So I also need to have the, make another right here, x, y. You have the negative versions of this. So I'll have negative 1, negative 2, negative 3, negative 4, negative 6, and negative 12. The products there would be positive 12, positive 6, 4, 3, 2, and 1. So graphing that, it's going to actually just look like the reflection over the origin. So I'm at negative 1, 12, not my graph, negative 2, 6, negative 3, 4, negative 4, 3, and negative 6, 2. Again, you will notice that these will never touch our y or x axis. And also notice that these have actually flipped positions. On the last one we had a graph in the first and third quadrants. This one's in the second and fourth. And that's because we have a negative value for our constant term. So that will move it over into the second and fourth quadrants. That's it, guys. It's time for your work time. A few things for work time. Remember, first, just continue to be awesome. And secondly, continue to help each other out, ask questions, work with each other, answer each other's questions as much as we can. And tomorrow I'll be back and we'll kind of sort through anything we have still questions on and go from there. So thank you guys, and looking forward to being back in the classroom tomorrow.